easy points. What is due today? There is a new checkpoint today. One can have a point. That's what I was looking for, Addison. You can have a point for that. There were 5 problems inside your notes that are due today that I've said for some time now. So no, good Lord, get it together. Okay, so if you're not done with that, when you finish your checkpoint, you want to finish that because when you leave the room today, I'm putting in a 0 for it. I'm actually going to show you how to do one of them. So surely to goodness, you'll write down my answer to one and at least have one of the 5 done. We would pray. Okay, let's go over. We're only going to do 2 problems today. Number 11 is a really easy one. Why? Yes, 3. You can have a point. Why don't you tell me what it is? I thought of that, and if you're thinking in your brain and you're trying to figure that out because you've forgotten, because I know you memorized it, but it's been a while. It's going to be 19, and how I think about it is I think of 7 and 7 is 49, so the last number's a 9, and my last number's a 1, so it's not 17. And then 18 and 18, 8 and 8 is 64, so my last number's going to be a 4. But he's right, 9 times 9 is 81, and that last number's a 1. So if you're having trouble remembering those perfect squares, that's one way. Every group but 1 get a point. Okay, what about those variables, that a, b to the third? Got to deal with those. 19 came out because 361 is a perfect square, but what about the variables?
Only a b.
Only a, b can come out, and what should be left under the radical?
A and b.
Yes, good job, Arturo. You're going to point. Perfect. Okay, let's do number 12. 12 is a little more difficult because 456 is not a perfect square. I need a perfect square number that multiplies to give me 56. So don't say 8 and 7 because neither of those get you to 56. I mean, they do multiply to 56, but neither of those are perfect squares. Those are the words.
Use 8.
You can't use 8 or 7 because neither of those are perfect squares.
4 and 14.
4 and 14 would work because 4 is a perfect square. So 4 is going to come on out, and I'm going to have 2 square root of 14 left. But I still need to deal with my j's. So Arturo get a point, and someone besides Arturo deal with the j's. J to the 9th. J to the 4th, and what's left under the radical? 1j. Thank you, Mammy. You can have your point. We're going to say 13 and 14 for tomorrow. We'll deal with 15 on Monday. It's fine that we're going to be a little behind on that. I just can't. There's only so many hours in the day. Okay, let's go to your notes and let's talk about some things. I'm a little heartbroken this morning based off some questions I've gotten, so I don't know if I talked to myself or if you're just having a moment. It's okay. Either way, I guess. Okay, so we started a new chapter. We just finished the checkpoint, and literally everyone in here, well, everyone in this room at this time, that's true. Everyone in the room at this time has already passed the checkpoint on adding, subtracting, multiplying, and dividing functions. You already passed your checkpoint. I just, again, want to remind you, adding, subtracting, multiplying, especially multiplying, not as easy as it sounds. You have to distribute. You have to combine your like terms. It does take some time. You got to get it together. And I'm especially always worried about division because some people have forgotten that there's a number we can't have in the denominator. Okay, so let's look at what you're supposed to turn in today. It's the page 77 study guide. It's like 2 more pages inside. It's the study guide and intervention on it. We talked about that. You probably have to show your work on a separate sheet of paper because you can't write that tiny. I want to help you with number 5. That's the only one I want to help you with. Why do I want to help you with number 5?
Because it's a fraction.
Every group can have a point, and it's because of the fraction. I want to help you with number 5 because of the fraction. Okay, so we're supposed to add, we're supposed to subtract, we're supposed to multiply, and we're supposed to divide. We don't have to practice function composition on this problem. What is the symbol for composition? What is the Simple. Thank you, Mammy. You can have your point. It looks like the multiplication symbol, except that the circle's not filled in. Good job. Okay, so they want us to add. So f is x squared minus 1. Heck, I could go ahead and write it all 4 times. X squared minus 1, x squared minus 1, x squared minus 1. They all start off with f. Now the first one says f plus g. So if I did f in purple, and y'all do g in green. So I'm going to add 1 over x plus 1. And literally I'm done. That's all I'm going to do today. Now, could we get a common denominator and try to make this look a little more complicated? We could. But that's all I'm going to do for the addition one. We're done. How is the subtraction one going to change? What's going to change with the subtraction one? Do I have to distribute with the subtraction one? What's going to change? How are these two going to be different? They're not the exact same answer. What's going to change? Yeah, say your words again, Hunter.
It's the subtractions.
It's literally, thank you, Arturo, and then Hunter can have a point as well, because I heard him trying to figure it out. It literally is just the symbol. Since it's f minus g, instead of a plus sign, it needs to be a minus sign. Still just minus and then the fraction. That's literally all we're going to do. Yes. That's literally all we're going to do. The only two that are complicated are multiplication and division. So we had f. We need to multiply it times g. And that kind of stinks because I got to multiply with fractions. So you remember what to do. You used to put your thing over 1. So if we multiplied across, we'd have x squared minus 1 in the numerator. X squared minus 1 times 1 is just x squared minus 1. 1 over times x plus 1 is just x plus 1. And that looks great. And I'm very tempted to circle that as my final answer, but that would be incorrect. There's still more than I can do. So let me say it again. I multiplied, and literally since I multiplied, the top ended up in the top, the denominator ended up in the denominator. No big deal. But sadly, I can still simplify this. How can I still simplify this?
X does not equal to
That would, oh my goodness, Arturo, you can have a point. So Arturo is catching on to the fact that we could not have x equal to -1, and normally he would be correct. Normally he would be correct. I mentioned the other day that we would love for something to happen first before we pick that no-no number. We would love to try to do something else first, and it actually works on this problem. It hasn't worked on our previous problems. It didn't happen on our checkpoint. It didn't happen on our notes. But my God, we've been practicing for it all year, especially with an x squared and a 1, because those numbers are pretty numbers. So I'm hoping to do something. I'm going to leave the x plus 1 alone. Is there some way we can deal with the x squared minus 1? Is there some way to factor that? Say what now, ma'am? It's perfect squares. X squared and 1 are both perfect squares, so I should be able to factor that. It's an easy factor. It's an easy factor that makes me want to cry at 8:30 in the morning. Okay, so what should I put on each parenthesis then? Okay, there is a 1, but what else do I put? Okay. So I'm not gonna cry. I'm gonna save my tears. No, that made me so sad. The whole thing just made me so sad. The whole thing made me so sad. Trying not to cry this morning. Why am I really excited about the fact that I could factor it? This could get your point. Why am I really excited about the fact that I could factor it? What's going to happen now? Say words again, Hunter. Yes, I'm literally going to say those two cancel out. So my final answer is just x minus 1. So Arturo was right. If we had a denominator, we would be worried that there's a number But actually, since we were able to simplify where we no longer have fractions, there is no denominator, and there is no number that's going to be restricted to our domain. There is no number because we canceled out the denominator. So that's one reason I wanted to work this problem, is finally we got what we wanted in life. So Arturo doesn't even have to worry about the denominator, because in the end of it all, there is no denominator. Oh, I'm so worried. If that was deep, then I'm about to blow your mind. I need you to stop talking and I give you points, because y'all are super chatty. Yes, Patrick. Okay. The last one is, if you were mad at the f times g and it all canceling out, then you're really going to be mad at this one. We're wanting to do f divided by g. So I've got f. I need to divide by g, but g is 1 over x plus 1. So we've got a lot going on. So let me write it on my post-it so I have a little more room. We've got x squared minus 1, all divided by 1 over x plus 1. I don't know about you, but 2 fractions is too many for me. Because we've got a fraction inside of a fraction. And so I don't know if you know this or not, and I pray you understand and will know this from now on, because I'm sure it's going to come up later on in your life. What did your math teacher used to say when you had a problem like this? She would say something about flip the... Did your teacher not say flip the second multiply? When you had to deal with fractions? You didn't have a whole unit on how to do this. They would just literally change the multiplication sign to... they would change the division sign to multiplication, and they would flip the second. Your teacher used to say flip the second multiply, meaning, hey, change 2 sevenths, flip it upside down, so now it's 7 over 2, and change that division symbol to multiplication. Okay, so that's the math behind this. If you understand it, great. If you don't, here's some key wisdom in life. If you have a fraction within a fraction, you know how 2 lefts make a right is always a joke? You know how people always joke that 2 lefts make a right. 2 rights make a wrong, or whatever. So 2 fractions make the fractions go away. So if you have a fraction divided by another fraction, the way we see 2 fractions in a row right here, x squared minus 1 stays in the numerator. X plus 1 actually flips to the numerator as well. It's like 2 fractions cancel each other out. And then that's terribly annoying, because what was supposed to be our easy problem, because every other problem, the division part was the easiest. You literally just put f, g, give me the no number, and you're done. And now suddenly our problem is as hard as multiplication. Why is that? Why is our problem now as hard as multiplication? As hard as multiplication now. Why do I do math? Because now we have to FOIL and distribute and do what we normally had to do when we multiply. We hadn't had to do that with a division, but we will now. X to the third plus x squared minus x minus 1, and I finally got to my final answer. But it's annoying because every other problem so far, division's been like 2 seconds. And now all of a sudden division took the longest. Heck, addition took 2 seconds. Subtraction took 2 seconds. Multiplication took 3 because we couldn't factor this morning, but that's life. That happens, I guess. You would think we factored enough. Anyway, moving on. Division's the only one that held us up, and so far division's normally the easy guy. The other 4 were yours. They've been yours for 3 days now. I feel like no on the arc. 40 days, 40 nights. How do you not have these 5 done? I do not know. Okay. Let's talk about what we talked about yesterday. So yes, Addition, subtraction, multiplication, division. Yes, these problems are due today. If you've not finished them after the checkpoint, that's what you need to finish because I'm typing in the 0 today. My gosh, today. Yesterday we talked about function composition. And I said there were 2 words we normally use to describe the problems because math teachers are lazy. What were the 2 words? Yes, 3. It's fog and golf. We tend to have fog and golf problems, so you can have a point. Today we might have other letters. Again, it's not always fog and not always golf. But we talked about how to do those yesterday. So you went home, you looked over your notes, I'll pretend. Did anyone have any fog or golf questions? Okay, well there were some easy fog and golf problems I skipped at the bottom of your notes, and we need to fix that now, and then it's your time to take your checkpoint. If you're trying to get super ahead in life, and you're wanting to go ahead and do all the things, we discussed yesterday, do fog and golf have to match? No. And most of the time they don't. But they're called inverses if they do match. So if you see something that says check with function composition to see if they're inverses, then they would match. Just FYI. That's what we're going to do tomorrow. Okay, here are the ones I want to do today, and there are similar ones on your checkpoint. Your checkpoint has 3 questions. 1 is a fog and golf, and 2 are like number 1. Jesus, take the wheel. I don't know. Find it in your pocket. It's what we did yesterday. Stop being so goofy. Okay, we didn't do these yesterday. The ones we did yesterday didn't have a -2 there. What did they have there? What did they have there instead? Every single problem we did yesterday, what was inside the inner parentheses? Thank you, 3. You can have a point. My God, 3's at least here today. Woo. Okay, so life's supposed to be easier today because we don't have x's. We have a number. We get to use a number now. So we still want to know, and I'm going to write it just for myself, we still want to know g evaluated at h at -2. We're going to start super inside the way we did yesterday. Yesterday, we would take h and plug him into g. Today, we're still going to take h and plug him into g, but we're going to make our lives a little easier. I'm going to go over here to the side and go ahead and figure out what h is at -2. And let's go ahead and figure out that number. Okay, so h was, at the beginning, h was x squared plus 6x plus h plus 8. It used to be that. Seth, go sit where he normally sits. Don Terrius, go sit by Addison. I can't deal with y'all anymore. Just move. You can have your spots back for tomorrow, but I can't deal with y'all where you are today. I just can't. Okay, h at -2. I'm literally everywhere I saw an x, I'm going to put a -2. So I've got -2 squared plus 6 times -2 plus 8. What is -2 squared? Positive 4. 6 times -2 is -12, and then plus 8. So what do I end up with at the end? 0. Thank you, ma'am. So we found h at -2. That number is 0. So our problem said, hey, I want to know g evaluated at h at -2. Well, we figured out this number already. This number inside is 0. We did it. So instead of g of h at -2, we now just want g of 0. Because you and I figured out h at -2 really is the number 0. So g at 0, well, let's see, g was -2x plus 1. But everywhere we see an x, we're going to put a 0. So I've got -2, 0 plus 1. And so -2 plus 1, -2 times 0 plus 1, what will my final answer be? 1. Yes. So you and I figured it out. So g at h at -2 really is just the number 1. So I know number 2 says 3a, but I just, oh my gosh, I can't with more variables this morning. Let's just stick with numbers. Scratch out the a. So we want to know f evaluated at g of 3. So first thing I do is go to the side and figure out g at 3. Well, g was negative 2x plus 1. But everywhere I see an x, I'm going to put a 3. So g of 3 is really the number, what? No. Yes, thank you, Reagan. Your table can have a point. Negative 6 plus 1 is negative 5. So I figured out this. It's negative 5. So I need to know f at negative 5. Now I've written way too much right there, so I'm going to have to go a little lower to do that. F at negative 5. F was 5 times x. But instead of x, I'm going to use negative 5. So what's my final answer? Say what now? Okay, thank God. Okay, so f at g of 3 is just negative 25. So I think when they use numbers, it's way easier than checking fog or golf. You don't actually have to do math. We're just plugging stuff in. You plug in the inside guy first. So we did g of 3 first, got a number. Then took that number and plugged it in the outside guy. I've even seen ACT problems where they go one more step and make you do it 3 times, like F, G, and H. Okay, I love you dearly. I need you to have your 5 done and show me